Hello, my name is Shahan Derkarabetian. I'm going to tell you about a project we finished up this year dealing with the phylogenomics of Triaenonychoidea, a group of Laniatores, including description of new species. So before I get started, I want to say that because we're doing Zoom, if you want to put the box with my face in it down in this corner, you won't miss anything on the slides, I promise. All right, so this is Triaenonychoidea. Currently has 110 genera and about 500 species and subspecies. It's morphologically very diverse. Well, not compared to tropical taxa, but for temperate taxa, it's very diverse. The range in body size from less than a millimeter to the group that Kaylin works on, about a centimeter in length. This superfamily currently has two families, Synthetonychiidae, which is only known from New Zealand, and Triaenonychidae with 4 subfamilies. Now, the Triaenonychids are much more widespread. You can find them in the temperate forests, and they're really diverse in the southern hemisphere, where you can find them in the former Gondwanan terranes, including southern South America, southern Africa, Madagascar, 1 species on the Crozet Islands, Australia, New Caledonia, and New Zealand. And there's also a few isolated taxa in the northern hemisphere. So I'm going to mention specifically a few genera because they'll be important later. First is the monotypic genus Montana from eastern United States. We have a new genus, which I will describe, from a single cave in Spain. We have monotypic Bumerinoa from several caves in Sardinia. Flavonuncia, which is one of the many genera you can find in Madagascar. And then finally, another new genus from Western Australia. So there's been a lot of work on Laniatores systematics, of course, and there have been quite a few studies that have included both families of Triaenonychoidea. I'm just going to show a few here. The first important one was a morphological study by Mendez, who recovered monophyletic Triaenonychoidea. The early Sanger sequencing studies and some of the phylogenomic studies did not recover monophyletic Triaenonychoidea. However, most of the UCE, the ultraconserved element studies or analyses that I've done, do in fact recover a monophyletic Triaenonychoidea, agreeing with morphology. More recently, there have been 2 important papers for this group. The first was a morphological analysis by Karaman. The most important finding was that he established within Triaenonychidae this tribe Bumerinoidae to include Bumerinoa from Sardinia, Montana from the United States, and Flavonuncia from Madagascar. Second was a Sanger sequencing study by Baker et al. And this was largely a biogeographic study. However, from a systematics perspective, there was a few important things. First, Triaenonychidae was not monophyletic, and the subfamilies were not monophyletic either. So this is kind of a representation of the Baker et al. Phylogeny. What you can see is that this genus Lomanella from Australia is a sister group to Synthetonychiidae, to the exclusion of all other Triaenonychids. The second thing is Montana and Flavonuncia were found as sister genera, agreeing with the work of Karaman. Okay, so those 2 papers kind of made it clear that a revision was needed. So the objectives of this project were, simple in text, but very complicated in practice. So first was the family level reclassification of Triaenonychoidea, and then systematics of the really diverse Triaenonychidae. So if you're familiar with my work, you know that I use ultraconserved elements or UCEs. You've heard a lot about them. I won't repeat anything except to say that they're very useful from ancient relationships down to populations, and we can sequence really old things. I've sequenced specimen from 1865 successfully, so it's really important for systematics work. Our taxon sampling for this project was really, really good. We had almost 80% of the described genera sequenced, and this includes some really old museum specimens for rare taxa. The missing genera, the vast majority of the missing genera are these monotypic genera, and the vast majority of those are ones that were described by Rower. So if you know his work, you know that they're not that important because they're just kind of oversplit genera anyway. we can place all of those in the phylogeny based on morphology. So here's the full UCE phylogeny of the data set, including outgroups. This has 704 UCEs. I'm just going to simplify this just to focus on kind of higher level relationships in Laniatores. So first, I'll point out that Triaenonychoidea is monophyletic. Next, you'll see that Triaenonychidae, the family, is not. Again, we see Lomanella, Lomanella and a new genus as a sister group to Synthetonychiidae. Next, we do find a relationship between Flavonuntia, Fu Montana, and another new genus from Spain, confirming the morphological work of Karaman. And then, of course, we have kind of the core Triaenonychidae. So in thinking about reclassification, we ended up with 4 families: the Synthetonychiidae or Synthetonychiidae, a new family, Lomanellidae, a new rank for Beumerinoidae, and then Triaenonychidae. So now I'm going to go through and talk about each of these a little bit. So first, Synthetonychiidae. This includes 1 genus with 14 species. It's endemic to New Zealand, where it is fairly widespread, but it is rare. These are all the specimens or collections we have in the MCZ. The vast majority of these only include 1, maybe 2 specimens. This genus is morphologically pretty unique. Fairly interesting, in my opinion. They're kind of hard to find. So one thing I'm doing is, of course, UCE phylogenetics or phylogenomics of this genus or the family. And this is still a work in progress. We're going to be getting a lot more specimens soon, but this is what I have so far. It's essentially 1 specimen from every collection I have access to. So this is coming soon. There is evidence for new species, of course. So next, the new family, Lomanellidae. In Amanda Mendez's dissertation, she had this excellent morphological phylogeny, and what she found was that the genus Lomanella was closely related to the family Synthetonychiidae, to the exclusion of all the other Triaenonychids. She named this group for Lomanella as Lomanellidae, the family name. However, because this was never published, it became nomen nudum. So with the help of Amanda, we formally name Lomanellidae, and it includes 2 genera, Lomanella here, and the new genus, which includes 1 species for now, which we call Abaddon. You can see some obvious differences. Lomanella are all kind of smooth-bodied, and Abaddon is covered in tubercles and spines. The genitalia for this family are relatively simple for Triaenonychoids. You can obviously see some differences in between the genera. Lomanella is very, very morphologically diverse in its own way, but there are some fixed differences. Okay, this family is found only in Australia, where it occupies a much more restricted distribution relative to the Triaenonychids. They're found in kind of southeastern Australia and Western Australia. The new genus Abaddon is only found in three localities now in Western Australia. Okay, now on to the new rank for Beumerinoidae, which in this group, we had samples for Flavonuntia, Fu Montana, and a new genus. The new genus we named Pteronicus. It includes 1 species. This was found in one cave in kind of northeastern Spain. You can see it's obviously adapted for cave life. Really long legs. It's completely lost its eyes. No black pigment. It's a very, very cool species. As a family, the Beumerinoids are kind of easily diagnosed based on genital morphology. Most obvious by the kind of the ventral plate that's like deeply cleft and articulated. Perhaps the most interesting thing is their distribution. Again, it's all the northern hemisphere taxa, Fu Montana, Pteronicus beumerinoa, and 1 genus from Madagascar, Flavonuntia. So this is obviously a really old family. Okay, now on to Triaenonychids. Here is the full phylogeny for only Triaenonychidae. First thing I'll point out is that there are only 3 nodes with bootstrap less than 80, so this is a very well supported phylogeny. Most important, you should not be surprised to hear that no subfamily is monophyletic. These subfamilies were diagnosed based on the structure of the sternum, and in the case of Sørensen based on tarsal claws. So we now know that, well, we've suspected for a very long time, but these morphological characters aren't good at the subfamily level, and we got rid of the subfamilies and we replaced them with letters. So for now, we just name these clades A through E. Some of the more diverse ones have multiple subclades. And the reason we don't continue with subfamilies, for at least for now, is because it's going to be difficult or impossible to find kind of diagnostic characters for any subfamily level groups because of high homoplasy and limited genitalic characters. Okay, so now that we have this phylogeny, we can ask some questions about Triaenonychids. And I'm going to briefly mention biogeography, just to say that we do a biogeographic analysis of Triaenonychidae in a paper that was just accepted this week in the Journal of Biogeography. I won't say much other than it's a very complex story and very interesting and important in my opinion. Okay, so now I'm going to talk about one of the many interesting aspects of the morphology of Triaenonychids. That has to do with hypertrophy of male genitalia. This was discussed in detail in Hunt and Maury, and I'm just going to kind of summarize it here.
Shahan, that's 12 minutes. Sorry.
Okay, thank you. Thank you. Here are some typical genitalia, an elongate truncus and a kind of short stylus. So here's what hypertrophy looks like. This is allobunus and thelbunus. You can see some obvious elongation. Gets even more hypertrophied in taxa like rhynchobunus and araucanobunus. And then it's most extreme in this little known genus called Cluniella from Eastern Australia. So this is obviously an excellent opportunity for study here. Okay, so next I'm going to switch to taxonomy, or kind of future work for systematics, and you should not be surprised to hear that there's a lot left to describe. Every single one of these arrows points to a lineage on this tree that needs a new name at the genus level for whatever reason. There are plenty of examples. I'm just going to point to the top one. This is a group of taxa that's found in Eastern Australia. I have 6 samples sequenced. Only one of them I can assign to a species and genus properly. The rest, I don't know yet. And of course, there are many new species to be described. I'm going to focus again on an Australian taxon because Australia needs a lot of work. This is the genus Triaenobunus. It is not monophyletic in our phylogeny. So just a bit of detail. The Triaenobunus species are all described from southeastern Australia. Everything up here is undescribed, and all these dots here are from recent fieldwork where we collected Triaenobunus where they were never found before. All of these are new species, and there's even some coming up on iNaturalist. And I'm going to end, I know I'm running out of time, with iNaturalist. It's been a great help for this project, specifically with our New Zealand research. And I'm just going to end with this example here. Prasmula unica was described in 1954 based on one female specimen, and no other specimens have been collected or recorded since, until earlier this year when this photo came up on iNaturalist. So as soon as I saw this, I got really excited and started emailing everyone at 6 a.m. So, oh, also there's some green Triaenonychids. It's pretty cool. So I'll leave it there. Thank you for your time. If there's no time for questions, you can put them in chat and I'll happily answer. So thank you.